All right, notes on rational functions. If you read the notes that I posted on the blog, I'm just going to do a couple of examples to go along with what was there, what is there. Let's get this pencil to work here. Okay, so problem one from that set of homework problems is the function f of x equals 2x over x minus 3. Okay, so following along from that worksheet, to find the vertical asymptotes, you set the denominator equal to 0. So you take x minus 3 equal to 0, and you solve it, and you get x equals 3. So that's the vertical asymptote. There's only one. So to find the horizontal or slope asymptote, slant asymptote, you look at the degrees. The degree of the numerator is 1. The degree of the denominator is 1. Since their degrees are equal, you take the leading coefficients. So the leading coefficients here are 2 and the 1 that's in front of the x there. And so what is it? It's y equals 2 over 1 or y equals 2. So that's your horizontal asymptotes. Zeros occur what? A function can only equal 0. So if the numerator equals 0, if and only if 2x equals 0 or x equals 0. So our zeros, we only have one, and it's at 0, 0. And this is also the y-intercept. Right? And so with these four pieces of information, we can draw a graph. Let's do this here. I'm going to use, where are my colors? Black. No. Use that. There's x and y. 1, 2, 3, 4, 5. 1, 2, 3, 4. 4. 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Minus 1, minus 2, minus 3, minus 4. Minus 2, minus 3, minus 4. All right, so here we go. First thing you want to do is put in your vertical asymptote, which is at the line x equal 3. So we've done that. Now we're going to put in the horizontal asymptote, which is the line y equals 2. Okay, so those are our asymptotes. Now we're going to get a cool color like purple and plot our zeros and y-intercept. There's only one of them there, and it's this guy. Okay. So what we know is along an asymptote, a horizontal or vertical asymptote, you always emanate from there. So we're going to come up like that. And then as we go to minus infinity, we have to do that. So it has to be this, the purple. And since it's a function, the other side is either going to do this or it's going to do this. But it can't do both because of it's a function and it passes the vertical line test. And since there's no more zeros, this one can't be the line, because otherwise there'd be a 0 somewhere over here. And so that's that. And it's just a puzzle. So you put together the asymptotes and the zeros and y-intercept, and you get this picture. Okay. So let's go over here to Desmos and look at this. This is 2x over x minus 3. And sure enough, it's the same. If you want, you can put in your asymptotes to see where they're at. Just to give you a feeling for how the function works. Okay. So that's the first example. The second example isn't from your notes, but you'll follow this for the last problem. So I'll say let h of x be, oh, I don't want red, hold on. I want blue. So we're going to let h of x be x squared minus 1 over x minus 2. Now, since the degree on the top is strictly greater than the degree on the bottom by 1, we're going to have a slant asymptote instead of a horizontal one. Okay, so let's do this here. Vertical asymptote, slant asymptote, zeros, y-intercept. And once again, the vertical asymptote happens when the denominator equals 0 or when x equals 2. I'm going to skip the slant asymptote for a second. We'll come back to it. So the zeros happen when the numerator equals 0 or when x squared minus 1 equals 0 or x equals plus or minus 1. Right, so we have zeros at, oops, wrong space. We have zeros at minus 1, 0 and 1, 0. So the y-intercept happens when x equals 0, and if you plug that into here, h of 0 is 1/2. Okay. So how do you find the slant asymptote? You divide the denominator into the numerator, long division. So you go x minus 2 divides x squared minus 1. X goes into x squared x times, so we have x squared minus 2x. And I'm left with 2x minus 1. Now x goes into 2x 2 times, and we can stop right there. We have everything we need. Because this is the slant asymptote. Y equals x plus 2. Okay. So just like the last one, we're going to put all these pieces of the puzzle together. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Minus 1, minus 2, minus 3, minus 4, minus 1, minus 2, minus 3, minus 4. Okay. So, vertical asymptote at x equals 2. Put that in first. Slant asymptote at y equals x plus 2. So this is what? It's a line of slope 1 with a y-intercept of 2. Okay, so now we have our asymptotes in there. Go back here to purple. Our zeros happen at 1 and minus 1, and our y-intercept happens at 1/2. So just following the asymptotes, we have that for our lower piece and this guy for our upper piece. Because if it was going to be along here, there would be another 0, and there isn't. So this guy doesn't belong there. And hopefully this helps.